Okay, it's getting to be winter time, which means gritty roads. Why is it that right before a snowfall, the roads all get gritty? They put salt down. Very good. Why do they put salt down?
So people can drive safely.
So that people can drive.
No ice. They don't slide.
No ice, so they don't slide. Okay? All very good answers. Today, what we're going to do is learn exactly why that happens. Yes?
Because salt increases the freezing temperature, lowers the freezing temperature of water.
Very good. Salt lowers the freezing point of water, making it harder for water to freeze and form black ice. That is what we're going to talk about today. Does changing concentrations of solutions change it in any way? Yes, it does. It alters the physical properties, such as boiling point, such as freezing point, such as evaporation rates. Does it matter what type of substance is added? No. Only thing that matters is how much of it is added. The more is added, the more it's going to mess it up. So, order the following substances in order of greatest effect to least effect. Now you're wondering, well, okay, so the more you add of both, the more it's going to mess around with the properties. How much of this stuff do you have? Actually, let's say you have one of each. Well, then it would be the same, wouldn't it, Mr. Marino? No, because you do not understand modern thermonuclear weaponry. Huh? We have missiles that are fired and can go into space, and in space they actually break apart into multiple warheads.
That's a bit scary.
That is scary. Back when World War II occurred, one bomb destroyed Hiroshima, and one bomb destroyed Nagasaki. Since then, we've discovered ways of getting these weapons up into space, and in space, they break apart into multiple warheads that can come raining down on our enemy and strike different locations. So one missile can take out multiple. So that's the problem with modern warfare. That's why we do not want to get involved in a nuclear war. Why? Because
Everything would die.
I mean, let's say that you are able to intercept in space 99% of all the rockets. Yay, 99%. That's pretty good. That's an A. No, you failed, because that 1%, the one that gets through,
Kills everything.
kills a bunch of people. Okay? That's why we do not want countries like Iran to get this kind of stuff. Okay? Or North Korea already has it. Okay? All right. So, what does this have anything to do with chemistry? Well, I mean, you can imagine it does. You know, the whole radiation and stuff like that. But what does it have to do with this? Well, I like to think of ionic compounds as these multiple weapon rockets. Why? Because ionic compounds have the tendency to split up into smaller bits. For example, sodium chloride is not made up of one thing. It is made up of sodium ions and chloride ions. So you get how much for the price of one? 2 for the price of 1. How about calcium chloride? How many pieces will calcium chloride break into? Calcium, chloride and chloride. You get 3 for the price of 1. How about sugar? Sugar is molecular compound. Are they different? Yes. Molecular compounds do not break down into smaller bits. So, how many pieces do you get when you dissolve sugar in water? You get 1 piece. So sugar will break down. So will sugar alter the characteristics of water? Yes. Will it alter it as much as the other two? No. Who's going to alter it the most? Because how many pieces?
3.
Who is going to alter it next? Most. Because? And who is going to alter it, but alter it the least? What do we call properties that can be changed by changing the concentration, by adding these particles to it? We call them colligative properties, which I think is a really cool word, colligative. Have you looked at the colligative qualities of this situation? I bet you haven't. Use that. I mean, people will be so impressed with this word, they won't question the fact that you probably used it incorrectly. Okay? Let us refer to the colligative properties of this situation. Before you get angry, have you thought colligatively? Maybe you should. That'll probably disarm them right there. I think the conversation, the argument will end right there because they're sitting there going, colligatively? What does that mean? What are 3 colligative properties? Boiling point elevation. So impurities are going to raise the boiling point of substances. Freezing point. This is what Jackson knew already. Impurities can lower the freezing point of substances. And vapor pressure depression. Oh, the vapor pressure gets down on the dumps. In the dumps? On the dumps?
In the dumps.
In the dumps. No, that's talking about evaporation. So it's going to prevent things from evaporating as quickly as it could. So you got a little brother and sister, and they're trying to evaporate water. Add salt to the water. It'll take longer. That'll be so funny.
Yeah, because they always try to evaporate water at my house.
They do?
No.
Oh, okay. I thought, wow, what a cool family. What is boiling point elevation? Raising the boiling point of a solvent by adding impurities. So, for me, that means I add salt to the water that I'm going to use to boil spaghetti noodles. Why? Because I know the chemistry. If I add salt, the water won't boil at 100. It might boil at 105 or 110, depending on how much salt I add. That decreases the cooking temperature. I'm lazy. I don't like to cook. So I want the cooking to happen as quickly as possible. So I will add salt to the water in order for the cooking time to go down. My wife says it's for taste. I look at her and go, pasta's not supposed to have any taste. So she assures me that it's for the taste. I look at her, I go, no, it's decreasing the cooking time by increasing the boiling point temperature. She goes, yada, 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 yada. I'm going to add salt for taste. Okay, fine. But I know that she is not needing to cook it as long because she's adding the salt. How about antifreeze? We call it antifreeze, but you know it's also anti-boil, right?
Yeah,
We add antifreeze to the water. At one time, cars had water in their cooling system. But back then, cars' engines did not run as high temperatures as they do in our modern engines. So water was okay. Water boiling at 100 was okay because the engine never got to get that hot. But now with modern engines, the engines get that hot. So you add antifreeze to your cooling system in order to raise the temperature of water sky high so that so it doesn't boil.
Would you die if you drank it?
Yes, and that's why animals die. It is, in a way, it's a sugar, so it smells sweet, but this is a very deadly sugar. So animals will drink it
and then die.
It kills their kidneys, destroys their kidneys. What is freezing point depression? It lowers the freezing point of a solvent by adding impurities. Okay, so it's going to snow. Because of friction, the roads before it snows are usually going to be quite warm. Cars passing by it warm up the car, warm up the roads. So that initial snow that falls on the roads immediately melts. Okay? The danger comes overnight when that water refreezes into ice. We call it black ice. Because people don't see it and they hit it and they slide. Okay? So they add salt to the road so that when that initial snow falls, it melts and it dissolves the salt, and now that salt water is going to have to get much colder in order for it to freeze. So it doesn't work great, but it works pretty good, especially down here in the south. Now up in the north, it's going to get cold enough for even the salt water to freeze. So they don't worry too much about salting roads. They have snow plows. We don't have snow plows. Making ice cream. We'll talk more about this in the spring when we go out and make ice cream.
All right.
Adding antifreeze to cars.
All right.
We here in East Tennessee, we just add pure antifreeze because antifreeze will boil at a higher temperature than our car should ever get and will freeze at a lower temperature than East Tennessee will ever get. But up north, it will get cold enough for even antifreeze to melt. So they add water to the antifreeze in order to lower the freezing point of the antifreeze. So in this case, antifreeze, you add water in order to mess around with antifreeze, not the other way around. What is vapor pressure depression? Lowering the evaporation rate of a solvent by adding impurities. This one is not nearly as practical for you guys. It's not stuff that you would be familiar with, but you can identify substances by its evaporation rate and by the way that impurities affect it. All right? What ways are we depleting our resources? Yes?
Would you say molecular what?
Molecular weight. Okay, so that is colligative properties. Let's change gears a little bit and talk about more practical stuff. So take a little break. In what ways are we depleting our resources? Well, nature conserves atoms. Atoms are not disappearing. Atoms are not being made. Molecules is the biggest thing. Nature conserves atoms, not molecules. So we can break down very useful molecules like oil or gasoline into atoms or molecules that are not useful. And that's when we're using up resources, that's what we're talking about. We're making things that are useful into things that are not useful. One of the things that we're doing is we're using up ores that have very high percentage of the stuff that we want. Mr. Wood, if you ever have a class, he used to be a mining engineer. So his job was to go into mines and figure out the ores that were there and whether it was cost efficient to actually mine in there. Okay, and what amazes me is that usually here in America they mine stuff that has only about 2 or 3% of what they actually want. That means 98% of the stuff is wasted. They don't need it. Okay, why? Because over the years we've actually gone through and we have depleted all the ores that contain larger percentages of the useful metals. Okay, so much so that we don't even mine for copper anymore here in America. We have used up all the ores that have high percentage of copper. It's actually cheap. We've not run out of copper, but we've run out of the ores that have high enough percentage that it's cheaper to mine. So for us, it's a whole lot cheaper to get it from another country than it is for us to go in and dig it up ourselves. Okay? So when we say that we have an ore that has a high concentration of copper, we say that its percentage composition is high. What is percentage composition? It is a fraction of a particular element in a compound. Let's determine percentage composition. What is percentage composition? The percentage of a given element in a formula. How much of a given element is in that formula in percentage form? How do you determine percentage composition? Oh, my friends. You know me, I love causing you pain. But even I can't make this one hard. This is middle school type stuff. So, take this down and we'll do a couple examples and you'll see how easy this is.
Yeah, the same thing you just talked about first.
Oh.
Do that one more for you.
No.
Is there one more for you?
Right now.
All right, let's do it. Step number 1, add up the masses. Sodium is 23 plus oxygen, 16 plus hydrogen, 1. 23 and 16 is 39 plus 1 is 40. So what do we do with the 40?
Divide by the molar mass.
23 divided by 40.
The number I don't know.
Excuse me,
Fif- 0.575, which is 57.5%, right? You got to move the decimal 2 places over in order to make it percentage. 16 divided by 40. What? No, you got to go more than that. 0.40. 0.40. Okay, which means it's 40.0%. And 1 divided by 40, I bet it's 2.5. How did I know it's 2.5? No. What do these percentages have to add up to? 100. So what's 57 and 57 and a half and 40? 97 and a half. What's left over? 2.5. HCl. H is 1. Chlorine is 35.5. Equals. What do we do with 36.5?
Divide it by 1, or divide 1 and 35.
1 divided by 36.5. 0.027. So that's 2.7%. How would you like to make a bet that this is going to be 97.3%? How did I determine that? I'm phenomenally intelligent. I can do this math in my head. I can also subtract from 100. Okay, now this one's going to be tougher. 63.5 plus 2 times 14 is 28, plus 6 times 16 is 96. So what's 63.5, 28, and 96? What? 187.5. Okay, where I get nervous with people is that they'll try to, this one's okay, 187.5. At this point they freeze up and they wonder, should I divide 14 by 187.5 or should I divide 28 by 187.5? And the answer is 28. It's the total.
Wait, is that 0.4 or 14?
2 parentheses 14.
96 divided by 187.5. So 63.5 divided by 187.5? 0.33. That's 33%. 28 divided by 187.5. What? 0.149, which is 14.9%. And 96 divided by 187.5. Okay, gang, sometimes when you add them up, it doesn't add up to exactly 100. I don't think this one's going to add up to exactly 100. It's because the 33.3, I think that was 33. That should have been 33.3%. I don't know. Sometimes if you're not careful and you're not consistent with rounding decimals, you're not going to get exactly 100. But you should get pretty darn close to 100. Last example, K2CO3, 39.1. $78.2 plus 12 plus 48. 138. 138.2. I was thinking, man, that's really... Okay, so 78.2 divided by 138.2. 12 divided by 138.2. 48 divided by 138.2. What's 78.2 divided by 138.2? 0.56, which is... What's 12 divided by 138.2? 0.08. That's 8.6%. And what's 48 divided by 136.2? 138.2. That's 34.7%. Easy as she goes, my friends. You have now completed the toughest part of chemistry.
It goes downhill from